Hey everybody, today we're going to talk about sort of an overview of the science that we're going to be covering in this class. So this is sort of putting a lot of the things that will be discussed in detail later into some kind of context so you can see how it all kind of fits together into kind of a big puzzle piece. So the main points we're going to cover today are that the Earth occupies this particularly unique location in our solar system, and that's what allows it to have this active and interconnected climate system that is, so far, we think, fairly unique to our planet. Our climate system is the result of interaction between the atmosphere, the hydrosphere, the lithosphere, the biosphere, and the cryosphere, and we'll talk about what each of these different spheres represents, and there'll be much more discussion on them in later modules. And then we're going to talk about how energy is exchanged between different parts of our planet through different processes. And we'll finally touch a little bit on electromagnetic radiation from the sun, which is a critical component of the climate system. So let's move me over to the corner here and we'll get started. So a little perspective on our Earth and its uniqueness is provided from this diagram, which shows the relative position of our planet Earth compared to the relative size of our planet Earth compared to many other planets in our solar system. The actual positions of them are not to scale at all. And so, for example, like Jupiter would be way the heck out off of this diagram relative to the sun. It's much further away. But it allows you to see sort of these main four rocky planets that are closest to the sun, and then these gaseous planets that are much further away from the sun. Of our rocky planets, there are two, Venus and Mars, that are relatively close to Earth, one Venus being closer to the sun, and the other Mars being farther away from the sun. And so you'd expect then, and it's true, that Venus is hotter than Earth and Mars is colder than Earth, and so Earth occupies this kind of perfect Goldilocks zone that is the perfect temperature. But let's look at the differences between these planets more closely. So Venus is a very hot planet. It's much closer to the sun, and it has this really massive atmosphere. In fact, in this diagram or picture of Venus, you can't even see the surface of the planet because it's covered in this very thick atmosphere. And the atmosphere is largely composed of CO2 gas. So it's a very insulating atmosphere that leads to a runaway greenhouse effect. The CO2 accumulates in the atmosphere over time because of massive volcanism that's happening on the planet. And because it has this really dense, thick, CO2-rich atmosphere, it leads to this really high surface temperature of about 480 degrees C or 900 degrees Fahrenheit. If it didn't have this atmosphere at all, the surface temperature of Venus would be minus 46 degrees C. And so you can see how the atmosphere of Venus really allows it to be much more insulated and protected, really heated as a result of this greenhouse effect, much more so than our planet Earth. On the opposite side of the spectrum is Mars, which is a little bit further away from the sun. Mars also is slightly smaller than Earth, and so it is thus has less gravity. You might remember from beginning physics that gravity is proportional to the mass of the objects, that two objects, so the sun and the Earth, and the sun and Mars. And so Mars has less gravity, and as a result, it's not able to pull the atmosphere down close to the surface. So the atmosphere just gets lost into space. It was thought that Mars had liquid water on it at some point in the past, just from the geomorphic landforms on the surface of the planet. But a lot of that water is now frozen in the polar ice caps. You can see one here, and it's also frozen in the soils of Mars now. And we think that a lot of the atmospheric water just left the planet because of this lack of gravity on the planet. So as a result of lower gravity, not lack of gravity, lower gravity, Mars has a very thin atmosphere. It is also, like Venus, composed largely of CO2, but because it's so thin, it doesn't really have a big insulating effect, and so it has relatively no greenhouse effect. Now, the surface temperature of Mars is predicted to be minus 57 degrees C, so slightly colder than Venus. But because it has this mild insulating atmosphere, it provides an additional warmth of 10 degrees, and the surface temperature is about minus 47 degrees. So it's still quite a bit colder than our planet Earth. And then we get to our planet, which is just right, just like Goldilocks and the Three Bears. We are massive enough to be able to support and retain an atmosphere, so we have enough gravity that we can hold all those gaseous molecules close to our surface and create an atmosphere that allows for us to have a oxygenated atmosphere. And we're also warm enough with our surface temperature being at 15 degrees because of our insulating atmosphere that we can have liquid water on the planet. And this is incredibly important for formation and sustaining life on our planet. And just wanted to show you this kind of cool overview of a satellite called the Kepler satellite. This was launched by NASA about 10 years ago. And it's a really fun satellite that is merely looking for the possibility of Earth-like planets in our solar system. And so what it does is it points itself at neighboring stars, and it looks for when those stars experience some dimming as a result of a planet transversing across the sun. And it looks at sort of how much the planet or how much sun dims, and it can tell you something about both how far the planet is away from that sun and the size of the planet. And we can kind of look at, how many Earth-like planets are there out there in our solar system. So I would go and check that out if you're interested in learning more about that. And so just a general comparison between these three rocky planets that are closest to the sun, excluding Mercury. We see that Venus and Mars have very similar atmospheres, largely carbon dioxide, so they both should lead to significant warming. But because Mars is so thin, it doesn't warm as much as the Venus atmosphere, which is constantly getting CO2 through volcanism. Unlike those two planets, Earth has a completely different atmosphere composition. We are mostly nitrogen and oxygen, which allows for plants and animals to breathe on our planet. But all of them have some amount of a greenhouse gas effect or a greenhouse gas effect in the atmosphere, which allows for some warming, just to differing degrees depending on how thick and how much CO2 is within each atmosphere. And so what I want to try to talk about next is the idea that Earth is this climate system that is composed of interconnections between all of the spheres that you see here. So the biosphere, the lithosphere, which is the rocky part of our planet, the cryosphere, which is the isolated part of our planet, the hydrosphere, and our atmosphere. And this is all a result of some perfect circumstances that operate on Earth, including that we have enough gravity that permits us to retain a relatively thick atmosphere that's thick enough and has the right composition in order to keep the temperature of Earth relatively warm. And this optimal temperature allows for liquid water to exist on Earth, which is important for life. Both the optimal temperature and the water are important for life to flourish. We have plate motion or plate tectonics, so movement of the lithospheric plates on the surface of our planet, and that allows for recycling of rocks, which is largely carbon, on our planet, and that stabilizes climate on the long-term time periods. And then the cryosphere also permits regulation of temperature by reflecting sunlight and storing a lot of water in the polar regions. And so it's kind of interesting to think about the climate systems of other planets because it allows us to see the unique circumstances that Earth has that allows it to give rise to the kind of planet that we enjoy living on today.